One of the problems facing man when he first begins to travel in space is whether or not he can properly orient himself and control the flight attitude of his space vehicle. The National Aeronautics and Space Administration has constructed a multi-axis test facility at its Lewis Research Center in Cleveland. With this facility, it is possible to reproduce any type of tumbling that a space vehicle might encounter when it is separated from its rocket booster in space. The multi-axis test facility consists of 3 concentric cages, each of which is gimbal mounted to permit independent freedom of rotation. Rotation is induced by high-pressure nitrogen contained in the spherical bottles shown on each cage. The nitrogen is ejected through small nozzles near the ends of each cage, producing a thrust reaction that turns the cage. Each cage can be rotated about its axis at rates of from 5 to 60 revolutions per minute. A combination of rotation first is to study the ability of the pilot to orient himself with instruments while tumbling. The second is to study the pilot's ability to correct for the tumbling by means of the nitrogen jet reaction system operated by the hand controller. The research engineers briefed the pilot regarding the tests to be undertaken and discussed with him the sensations that he might expect. The pilot ascends to the test chair in the innermost cage. This chair has been constructed of a plastic that is specially molded to accommodate the pilot's body. As an added feature, the pilot is restrained in the chair with straps and a chest harness to prevent shifting of his weight during the tests. Only his arms are free to move. The pilot can communicate with the test engineers and the data collection center by means of a radio. The pilot has an on-off type hand controller which he operates with his right hand. The left hand is free to operate the radio transmission switch. The pilot's hand controller can start nitrogen jets that will pitch, roll, or yaw the yellow cage in either direction or in any combination of these directions. He can thus counteract the rotation induced in the 3 cages by the test engineer in setting up the test conditions. The test engineer starts the 3 cages rotating in roll, pitch, and yaw by means of the nitrogen pressure jets at the rates designated for the test. When the desired condition of rotation is reached, control is given to the pilot, and he then proceeds to fly the space vehicle. By the proper operation of his hand controller, the pilot can orient the vehicle into an upright position while the outer cages are still rotating. The pilot's ability to control the tumble of his vehicle and his reaction to these high rates of rotation are recorded, as well as the length of time required for him to recover from simple single-axis maneuvers to those involving rotation about all 3 axes. The results of this investigation will permit an estimate of some of the difficulties to be encountered when man first ventures into space, as well as provide a degree of training for future astronauts in the attitude control of a space vehicle.